To understand regression, we have to first understand selection bias, and that's really the connection with experiments. If we were doing experiments all the time, we would not need stata, okay? We would be able to just compare means and life would be pretty straightforward, but there are many problems for which we are unable to do experiments. So let's just dig into that and figure out what the source of selection bias is. This is really a review in a sense, but I'm going to put it in the context of my experiment on electronics, and then I'm going to move on to another application that I think demonstrates how regression can eliminate selection bias. So let's go back to electronics. Let's talk about the electronics in the classroom. So think about students, your students perhaps. If they're not allowed to use electronics, they have a test score of Y0. If they're allowed to be distracted by their phones, they have a test score of Y1. The treatment in this case is whether they are allowed to use electronics or not, or maybe it's whether they actually use electronics. For now, we don't need to worry about that. There are many problems like this, of course. Another example that I like is health insurance. Will you be healthier if you have health insurance? Of course, that's a big question in American domestic policy, but let's stick with the one we've talked about so far. So the problem here, as Alberto called it, the fundamental problem of causal inference is you'll only ever see one of these. You'll not see the other. You'll see Y0 if D is switched off, and you'll see Y1 if D is switched on. But we imagine this is meaningful. For everybody, there's a difference, Y1 minus Y0, and that's the unknowable individual electronic causal effect. How much more you would learn, how much more economics you would learn if you were not distracted by your telephone. Okay, well, let's think about how to estimate this. So in terms of population quantities, this is the difference in test scores, final exam scores, for people who use electronics, and this is people who don't use electronics. Now, of course, when D is switched on, we think of it as like a switch. It's either 1 or 0. You get to see Y1, and when D is switched off, you get to see Y0. And then I could do a little trick here, add and subtract plus minus E of Y0 given D equals 1. Okay, and again, this is kind of a recap of stuff Alberto did. And I find out that the naive comparison of people, the test scores of people who do and don't use electronics, well, there is a piece of something in there that's interesting, the average causal effect on the treated, TOT, the treatment effect on the treated. But then I have this term here, selection bias, and that has to do with the fact that the people who have their computers on in class are probably different from the people who have their computers off in class. And therefore, if we compare the test scores of people who do and don't use electronics, it's likely to be misleading. In particular, the Y0s of the people who have their noses buried in their phones are likely to be better or worse, would you say, Edvin?
Worse.
Could be worse, yeah, so that's what I think. Better students are just anyway more attentive, and so it's kind of a sign that you're paying attention, that your phone is off and put away. Of course, maybe you're a high value of time and you're too busy to pay attention. That's what my MIT students would say. My MIT students are too busy to come to class. They have more important things to do. Who knows how it goes? The point is that this is almost certainly misleading as a measure of causal effects. Well, unless, okay, we could find a way to make this term go away. And the way that we make that term go away is by randomly assigning D. Then D is independent of Y0. Now, I'm going to do a little modeling trick here because I'm not really interested in the heterogeneity of the problem. I'm not really interested in the fact, and at this point in my discussion, I'm not really interested in the fact that the average treatment effect on the treated might differ from the average treatment effect kind of unconditionally. So I'm going to switch to constant effects, which is like saying that there's some Greek letter that gets added on to y0, and that becomes y1. And the reason it's Greek is we think of our parameters as in, we label them in Greek. Okay, so that's how you know they're constants. So let's say the causal effect of electronic use is kappa. I happen to think that's a negative number, but whatever. And then this comparison, if I had random assignment, okay, this comparison would go away. The y0s would go away, and then this would just be the thing I care about, which is that constant causal effect kappa. So the key lesson here is that when you have the luxury of randomly assigning a treatment, then you make it by design independent of potential outcomes, and random assignment removes selection bias. Now that's actually, that's not specific to constant effects, but I just want to focus on that, and I don't want to worry so much about the details. Okay, so that's kind of by way of review. Let's go back to school. Hey, where'd you go to school? And does it matter? Okay, so that's my question. Where'd you go to school, and does it matter? Okay, and since I'm a labor economist by training, when I ask, does something matter? Usually what I mean is, does it matter for your earnings? Okay, so let's look at an example where we don't get to randomize, but I still think you can estimate the causal effects of something interesting, and that's the consequences of going to different sorts of colleges. And I'll classify the colleges in various ways. So one way to do this would be to say, well, some of us went to very selective schools, and some of us went to less selective schools. So that would be interesting. And of course, selective schools are generally more expensive. So we could also ask, is it worth paying? I'd like to have a simple dummy treatment. So I'm going to take this example, which is based on work by the late Alan Krueger and his co-author Stacey Dale. They asked whether it matters if you go to a more selective school like MIT. Then selectivity, it's kind of a little tricky. How should I measure that? Okay, so I'm going to simplify that and ask whether it matters if you go to a private school. Okay, as opposed, most of us, well, if you grew up in the United States, you have this classic dilemma, or at least your parents do. Okay, they could send you for very low money to the state school in the state that you live in, or they could pay big bucks and send you to a fancy private school like MIT. And for the pleasure of going to MIT, it'll only cost you about $75,000 a year. So, is that money well spent? Now, you could certainly, this is a good problem because, I can think about potential outcomes. People go to MIT, and maybe say you go to MIT and you come from Virginia, you could have gone to the University of Virginia. So, and what would happen to you, Or if you come from Texas, you could have gone to the University of Texas, maybe UT Austin, okay? I have a couple graduate students who, for example, got into Harvard, one from Virginia. She went to the University of Virginia. Another from Texas got into Harvard, went to the University of Texas. Well, they're professors now, at Harvard and other good schools, but, if they had actually gone to Harvard, they might be professors at MIT. They might have a good job. So, there's consequences. So is it worthwhile? Does private education pay? This is relevant, of course, for policy as well, because it's not just a personal, obviously it's personal, and probably many of you have experienced this through your children, when you advise them on where to go to school. And you may remember thinking about it yourselves, but for those of you who are my age, it didn't used to matter so much because private school didn't used to be so expensive, but now it's incredibly expensive. So these are the potential outcomes. Y1 is my earnings if I go private, and for the purposes of this, one of the things economists are good at is kind of abstracting and simplifying and getting to the essence. So I'm not worried at this point that there's lots of private schools and they're different, and within that category, I'm just going to lump them together. And then there's Y0, which is the counterfactual if I don't. And that's well defined for everybody. One reason I like this, so partly I'm speaking to you as students, but I also understand that many of you are instructors. This is a great example for your students, okay? Wherever you work either at a private or a public school. You can try to get your students to think about this as an actual decision that they have made, and they wondered about the counterfactual. And it's very good for motivating econometrics as interesting and relevant. And also you'll see, because the results are so clear, it generates a lot of great discussion. So I start to say, you know, you guys, you're all, even though MIT, they're all scientists, whatever, actually they all go work on Wall Street just like everybody else. And, you know, the people they work with, for the most part, will not have gone to schools like MIT, because going to MIT is a zero probability event. Most people in the United States go to public schools, but a minority do pony up for private. So they'll be forced to think about, you know, the guy in the cubicle next door or the gal in the cubicle next door, you know, made a different decision. So I ask my students to think about whether MIT matters for them, and I point out that Michigan is cheaper. Okay, so this is the potential outcome story. And actually, we have a video of this in the Marginal Revolution series that you can also use for your instruction. I won't take up class time today to show it to you, but if you Google Marginal Revolution University, there's a nice kind of 8-minute video version of this decision. Okay, so now of course you have to confront the fact here, if I just compare people who go to different sorts of schools, then you know, I'm likely to find, and I'll show you this in data, you know, people who go to private school generally have higher earnings later. So, you know, I'm thinking about a longitudinal study. Take a group of people, they're young, they're applying to college as juniors and seniors in high school. Then they go to college, then they finish college, then they get jobs and they work. So there are some data sets that allow you to trace that history. Not very many, but still, it's possible. And the data set that the Dale and Krueger study, 2002 study uses is called the College and Beyond study. And it allows you to actually do that empirically. And of course, there would be an experiment here that would answer this question. I've been working with I'm friendly with the MIT admissions officer, and I've proposed that he randomly admit and reject some of our students. I'm confident that the students will never know the difference, because the whole college admissions thing is completely opaque to the students. We saw that in the court case recently, the Harvard court case. Nobody really knows how it works, so they won't find out. And we'll learn a lot from that, like we would learn whether MIT is really worth paying for. Of course, he's fearful of what the answer is there. Well, anyway, I don't know. But he has not yet agreed. So in the meantime, we have to find another way to do it, maybe by running regressions, okay? So I want to show you, and it's really quite remarkable, that regression can kind of bring us pretty close, I think, to the experiment of my dreams here, where I'm randomly assigning people to go to colleges that are public or private, or any difference. Okay, so I'm going to work through a little bit of math on this, because even though I'm pretty sure that everybody in the room has experienced regression, either as a student or is now teaching regression, but I do have a kind of a way of explaining it that I think differs from the traditional presentation. So I'm going to take some time to do that. So again, the first thing I want to do is I like to label parameters in Greek, and I'm not interested in heterogeneity. I understand that there's a world of heterogeneous effects, and private school may be good for your children, but not mine. Let's just punt on all that, not worry about that, and just say that there's a constant causal effect. And then this is just notation, so I'm going to say the mean of Y0 is alpha, and then this is the random part. Okay. Now, without actually doing an experiment, P being private would be correlated with y0. And since the random part of y0 is eta, that's the same thing as saying that the conditional mean of eta, which by construction has an unconditional mean of 0, but the conditional mean of eta would not be independent of p. It would vary as a function of p. What we said just a few moments ago, the y0s of the private kids are likely better, just like the y0s of the people with their phones off are likely better. Okay, so that's going to confound my naive comparison, but I'm going to fix it. And the way I'm going to fix it is I'm going to assume I have some remarkable variables, which I'm going to call controls, and they're a vector, they're a set, and I'll label them x. And I'm prepared to assert, and this is an identifying assumption. It's an assertion that, if true, produces causal effects. Okay, that once I condition on these things, p no longer affects y0. And what that means, given this, is that E of eta given p and x is a function only of x. In other words, mean independence is what I'm asserting. Also, that's by way of simplification. I don't really care about the distinction between things that are correlated and things that are dependent, or things that are mean dependent and fully independent, okay, because I'm working on very basic ideas here. And so there's really two key assumptions here. One is that once I know this amazing set of controls, the people who go to private and public have the same y0s. And then I'm going to add on a functional form assumption, which is that the controls predict y0 linearly. That I don't really think of as restrictive, because the controls can be anything, and I can be very flexible there with lots of dummy variables. And you'll see, in fact, that's the trick that we're going to use. We can always use dummy variables to classify things, and then that's really non-parametric once I'm using dummies. And if the conditioning variables are continuous, I can put polynomial terms, and again, I can expect to fit that functional form. Okay, this is the functional form that I'm approximating. Okay, what's important is the way this regression is structured. Okay, it has a particular structure. I think of this as the modern regression model. It's not visible in most of our textbooks, where there's just a bunch of regressors and there's like a model, okay? There's something special going on here. Beta is the thing I care about. The regressors are not all created equal. The whole purpose of this regression, the reason the regression contains x, is it makes beta causal. But I don't actually care about the coefficients on the x's. I should look at them to make sure they're sensible. So if, for example, there's dummies for race and sex in there, I should maybe look at that and make sure that they sort of look like conventional results for differences by race and sex, just to make sure there's nothing wacky with my data. But the purpose of controlling for race and sex, or in this case, a better one would be, high school GPA, which is a good control as far as measuring applicant ability. Okay, I should look at that. But the gamma itself is really inconsequential to me. The only reason it's in there is I'm putting these controls in the hopes that the coefficient here has a causal interpretation. And in particular, given these assumptions, and this is what we call a conditional independence assumption combined with a linearity assumption, okay, that supports the causal interpretation of regression. Now, there is a way to check it. I'll tell you, limited way to check it anyway. You can investigate whether it's likely to be true. One thing I don't need to worry about, and this is a difference between perhaps the way some of you learned about regression and the way I'm explaining it. This U is actually the residual from this piece, okay? In other words, my model is constructed so that eta equals gamma prime x plus u. Since this is the residual from a regression, in this case a conditional expectation, it is surely uncorrelated with x. There's nothing to discuss there. Okay, that's the way I've defined it. So I know a lot of people learn about regression. They say, well, I'm worried that the regressors are correlated with the errors. That's meaningless here. It's meaningless for two reasons. First of all, it is by definition the random part of y0. And so it's surely uncorrelated with whatever I conditioned on in the model. And then I've maintained this conditional independence assumption, which is that the y0s are independent of both p and x. So of course, the random part of the y0s are independent of p and x. So I can't really think about the regression in terms of regressor error orthogonality. What I have to ask myself, and this is really all that matters, is by virtue of putting these guys in here, have I increased or made it, at least increased the likelihood? Ideally, I've made it happen so that the coefficient on P is the causal effect, okay? I have created a stratified randomized trial. That's really what I'm saying. I have these amazing conditioning variables, something I can throw in there, and now it's mechanically, of course, very easy to do. I throw it in there, but really what I'm asserting with this conditional independence assumption is a stratified randomized trial. Conditional on X, it's as if I was able to get the head of MIT admissions to kind of randomly take and randomly reject some people, okay? And then I've added on top of that this functional form, okay? Well, you know, that's a long road to hoe and not very plausible in most cases, but you know, that's also a good lesson for your students that, you know, research design is hard and most econometric studies are probably not very convincing and should be viewed critically. But I'm gonna work an example that I think is reasonably convincing. At least it's as convincing as observational, non-experimental estimates ever get, okay? So here are the data from the college and beyond sample. The college and beyond sample has data on people who went to these 30 different schools. Now you can see it's quite a mix of schools, and some of them are public and some of them are private. This is quite a selective group. By the standards of American college, this is at the upper end. You know, it's got schools like Stanford and Penn, and Yale, but it's also got some less selective schools like Denison, and it's got some big public schools like Miami and Michigan and UNC. Now, on the public end, they are also selective, but it's a pretty good set. It's a pretty diverse set. Everybody here in this data set is a graduate of one of these. And it seems natural to ask, you know, are these decisions consequential? So here's a good one. Suppose you're from North Carolina. You know, you could have gone to Duke, let's say, if you're a very good student in high school. You could have gone to UNC Chapel Hill. What's the difference? Well, you know, people said there's a lot of differences between Duke and Chapel Hill, but one clear difference is Duke, if we look here, Duke has much higher, that's the SAT score. So Duke has an average SAT. This is the two-score sum on the scale of 0 to 1600. Okay, so the average SAT at Duke is 1226, and the average SAT at Chapel Hill is only 1000. The other thing, now these numbers are kind of laughable, so you're allowed to laugh here. The tuitions are very low. Okay, so tuition at Duke is $3,052. That's because that's current dollars in 1976. Okay, so don't make too much of that. Okay, of course today Duke would cost like MIT about $75,000 a year. That would be tuition plus living expenses. But the main thing is, okay, well, Duke was 3,000, but UNC Chapel Hill was only 500. Okay, so it's really, you should think about the ratio. So you're paying a lot more to go to Duke than UNC. Actually, there's a kind of a cool thing here. So this is kind of me personally. I grew up in Pennsylvania, and so my state school was Penn State, and I could have gone to Penn State, okay, and paid only $1,000. Oh, this is my parents. I'm speaking on behalf of my parents. Okay, but instead I went to Oberlin. I grew up in Western Pennsylvania, and Oberlin is very near Pittsburgh, where I grew up. So somebody paid for me to go to Oberlin. Okay, I don't know why they wanted to do that, but and so they paid a lot. So was that a good deal or not? You know, what's my counterfactual? And now I'm going to show you a way to find out. So the Dale and Krueger study analyzes these data. And the key insight that's in the Dale and Krueger study, and this is really, I think also, this is where the hard work of econometrics is kind of coming up with these sort of ideas. So the key insight in the Dale and Krueger study is, well, we actually have in this data set information about where people apply. And that's very informative about what kind of student you're likely to be and what your prospects are. Really, that's kind of a good measure of your academic ambition, and it may be a good predictor of your Y0, okay? How much you want to invest in accumulating skills. And the data set also has information about where you were accepted. So the Dale and Krueger idea, and Steve Pischke and I borrow this in our book, is conditional on the sets of schools that you applied to and were accepted. So once I know that you applied to UNC and Duke and you got into both, now it's sensible to say, okay, well, you went to Duke and you and I applied to UNC and Duke, we got into both, I went to Duke, you went to UNC. Or you and I applied to UNC, Duke, and Oberlin, okay, and we got into all three, but I went to Oberlin and you went to UNC. Okay, that's a very well-controlled comparison, okay? It has a lot of information about your ambition in terms of where you applied, and then that admissions office, they dug deeply into your portfolio of accomplishments in high school, okay, and measured you, okay, and probably they measure you up pretty well because they get, a lot of experience doing that. So here's the idea in a nutshell. Now this is stylized, and I've turned it into the public-private story. So there's private schools and public. This is made up. So there's 3 private schools, Ivy, Leafy, and Smart, and there's 3 public schools, All-State, Tall State, and Altered State. Okay, and the idea is that we're going to look at students who are similar in the following sense. Here's 3 students in Group A, and they applied to 2 private schools, Leafy and Smart, and 1 public school, and they got into one of each. They got into Smart, and they got into Tall State, and then 2 of them went private, and 1 of them went public. That's apples to apples. Okay, that's a good, well-controlled comparison because the students in Group A are similarly ambitious, having applied to 2 private schools and 1 public school, and they're similarly evaluated in terms of their capabilities, okay, or at least their opportunities, okay, by admissions officers, okay, and so, they each got into 1 school. They weren't good enough to get into Leafy, but they got into Smart. And here's another group, okay, and this group applies to Ivy, okay, and gets in, and applies to 2 public, okay. So this group B is 2, this group here has 2 private, 2P equals 1, and this group here has 1P equals 1. And you notice that the group that's more ambitious, that applies to 2 private schools, here's their earnings. So this is the actual outcome in the Dale and Krueger data. It's people applied to college in 76, and then we actually see what they earn in 96. And on average, this group has higher earnings, but that's irrelevant as far as the causal effect of college goes, because that just tells me that it's these higher income people that are more likely to target more selective, more expensive schools. What I want to do is make comparisons within Group A and within Group B. And notice something else. There's a lot of students that I'm just going to throw away. Group C and Group D. I'm going to throw away Group C and Group D. Okay, why is that? Who could tell me why is that? Group C is of no use to me. Okay, why is that? Why is that?
For the public.
Linda, that's right. So Group C guys, they didn't even try to apply public, so how could I learn anything from them? Okay? So I should chuck them out of my data. Okay? Well, you can't say that about Group D, Osai, but why the Group D guys are also useless to me. I should chuck them out of my data.
They applied only to the public schools.
Group D?
Yes, Group D.
No, not exactly. They applied to private as well.
Admitted to the public.
Exactly. They didn't get any private offers. Too bad for them. But I'm not going to learn anything about them, okay, because they never had the chance to go to a private school. So that is exactly the Dale and Krueger research design is to, now this is a great data set. You don't get a data set like this every day, but there are such empirical opportunities out there and they exploit it. And actually the Dale and Krueger study asks about selectivity, not public-private, but we want to simplify. Okay, so if I was just going to run on my made-up data, I would keep these guys, and I would pool group A and B, and then I would control for whether you're in group A or B. And since there's only two groups, I could just do that with a single dummy variable, which equals 1 for group A. And then I'd have my private coefficient, okay? But that would be a very small sample. So in groups A and B, I have 5 people. So now let's look at the real Dale and Krueger regression as re-engineered by Pischke and me, okay? So now one thing is, the original Dale and Krueger idea was, I'm going to look at exact matches. So I'm going to find people who applied to Oberlin and Penn State, and then they made choices. Okay, there are such people in the data set. In other words, of the original 14,000, a couple thousand you can find a mate where they applied to and were admitted to exactly the same. Okay, but you could see that's very demanding. So instead of looking at exact matches, they propose using Barron's selectivity groups. So a Barron's selectivity group, colleges in the United States are classified by their selectivity. So you have schools that are, competitive. Say BU is competitive. And then you have schools that are highly competitive, like Michigan is highly competitive. And then you have schools like MIT that are ridiculously competitive. I don't know if that's a Barron's category. But anyway, the schools are grouped into categories like that. So when we want to say that you and I are similarly ambitious, we won't require that you and I applied to exactly the same schools as far as the name of the school. You and I applied to the same mix of Barron's selectivity. So for the purposes of this exercise, Yale and Penn are the same. Okay. So then there's 151 such groups in the data. There's 151 different possible combinations of selectivity where the people in the group applied to the similarly selective schools and then were offered places at similarly selective schools. Okay, and so the regression is log y, that's the log of my wages later on, okay, 20 years after I'm making this application decision. And the regressor of interest is the dummy for private. I have some stuff about me, like my own SAT score here and my parents' income at the time I applied. And then these are the key controls. How ambitious was I? And what were my opportunities? Okay. Again, the outcome is, I'm a labor economist. The outcome is wages. Okay. Why is it a log wage? Why is it a log wage on the left-hand side? Do you remember this? Log wage on the... It's going to be a percent, right? So the coefficient on P is going to be a percent. Okay. So that's the key regression. And let's see how that comes out, okay? So the key assumption before we look at the results, condition on this stuff. These are my x's. This is the regressor of interest. Y0, this is my assertion, doesn't depend on P once I condition on this stuff. And then I enter it all in linearly, okay? So that's the conditional independence assumption. So here's some regression estimates. And this is in the sample for which we can do the Barron's matches, the Barron's selectivity matches. And what it reveals is unconditionally, so just run a regression on a dummy for private. And of course, if I just run, and we'll do this in some detail shortly, but if I just run a regression on a dummy for private, that's the difference in earnings, public versus private. Just like if you have a group of men and women and you run a regression on a dummy for female, that's the male-female wage difference. Or if you have a group of immigrants and natives and you run a regression on a dummy for immigrants, that's the immigrant-native difference. Okay, so the uncontrolled mean difference is just a regression with a single regressor. And what this reveals is that the graduates of private schools indeed earn more than the graduates of public schools. It's about 13.5 log points, which implies a percentage earnings advantage of about 15 points, because the actual percentage difference is always a little higher. And the standard error is 0.5 or 6, so it's statistically significant. Okay, so this is a statistical fact that's not too surprising. Graduates of private schools earn more than graduates of public schools. Okay, so the first thing you want to do is say, okay, well, that's, pretty naive. I don't control for anything there. So let me control, for example, at least let me control for your SAT score. So this is the applicant, thinking back in time. So I'm looking at people who are adults, and I'm saying, okay, well, what was your SAT score when you were trying to get into college? Okay, so stick that in as a regressor, divide it by 100 because that's a natural unit. So every additional 100 points of SAT is associated with 4.8, 5% higher earnings. Okay, that's interesting, but I don't care too much about that. What I care is that does change the private school advantage. It reduces it somewhat, but it's still pretty big. It's about 10%. So once I control for the fact that people who go to private school generally have higher test scores, the private school advantage falls a little bit, but it doesn't go away. Okay. And again, this is the thing I'm interested in, and these all play the role of controls. And let me ramp it up a little bit by putting in a whole bunch of good stuff about you that's good to know, like your parents' income, and whether you're female, and whether you're a racial group, and whether you were in the top of your high school class. You see, well, people in the top of their class earn more, and whether you were an athlete, athletes earn more on average. Okay, I mean, not an athlete today as a worker, but you were an athlete in high school. Okay. So conditional on all that stuff, the private school thing falls a little bit, but it's still pretty big. It's still about 9 log points, which translates into about 10 or 11%. And it's statistically significant. Yes, ma'am. You have a question?
Can you just interpret the effect as parental income?
Yes, I can, but I don't remember how. I don't remember the units of that. There's some index there that Dale and Krueger created. So that's a good question, but I don't remember the units. It's not dollars. It's not dollars. Yeah. No, but it's a good question. I don't remember that. So, but the main thing is it's sort of just a way to measure that, right? I don't care too much about those units because I don't care too much about those coefficients. The purpose of putting in the parental income coefficient is to increase the likelihood that the private school effect is not just picking up family background. And I see from the fact that that's a very precisely estimated effect, that however I've measured parental income, it's an excellent predictor of the child's income.
There you go.
Yeah, that's a key point. Yes, so good you mentioned that. Okay, so conditional on the usual suspects, you might say, it's still the case that it seems to matter whether you go to private school. But then what happens over here? Over here, I move to alternative models. Now, this is also a presentation point. This is a good way to present regression results. Each column is a model, different controls, and I'm watching how this changes as I add more controls. So here's one control, and here's many. And then what's going on over here? The difference between columns 4, 5, and 6 and columns 1, 2, and 3 is columns 4, 5, and 6 have these guys. They have the information coded as a set of dummies. Okay, what sort of schools did I apply to and where did I get in? That's the difference. Now, I don't actually care, what those dummies tell me themselves. So I don't report them, but I do signal to my reader that they're there, and that's this bottom row. And look what happens, okay? Once I know where you applied and where you got in, the private school effect disappears. Conditional on application and admissions, conditional on application decisions and admissions outcomes, where you actually go, at least as far as public or private, does not predict future wages. Does not predict your wages as an adult. And it's small and it's not statistically significant because the standard error is 3.8. So I've taken this 9% and I've turned it into a 0. And the other thing that's remarkable here, and we'll see why this is remarkable shortly, is sticking in my own SAT, couldn't care less. Sticking in all this other stuff about me, like whether I was an athlete. It's still true that being an athlete is a good thing. It predicts wages. And it's still true that being from a family with high income is a good thing in the sense that it predicts higher wages. And it's still the case that the race and other things matter. But the private school effect is a robust 0. So, this regression really raises some great questions, which is, what am I measuring in columns 1 through 3? What am I measuring in columns 1 through 3? And this is what I ask my students. What am I measuring in columns 1 through 3? And how should I think you're going to lose your phone, man. What am I measuring in columns 1 through 3? Okay, and there's a word for that. You want to tell me what it is? Selection bias. Okay. The reason people who go to private school earn more than people who go to public school is they were destined for that. That's not a causal effect. Okay. This is not proof that the private school earnings advantage is really 0, but it's strong evidence for that claim. Because once I know where you were headed, it doesn't actually seem to matter where you ended up. There's another thing that's going on here that's important, which is this robustness across columns in columns 4, 5, and 6 that we'll get to. So I love to show this to my students because, I think it's counterintuitive. And of course, it's not what your parents thought when they paid your private school tuition. And it's probably not what a lot of you thought when you were thinking about where to send your children, that there would be no earnings advantage. The original Dale and Krueger result was not only does it not matter whether you go private or public, that I can replace this with the average SAT score of the school I went to. So, does it matter? If you go to MIT, you get to go to college. Well, if your kid goes to MIT, you get to go to college with kids that are 100% toll-free, as they say, okay? There are 800s all around. What is the advantage to that? Well, the Dale and Krueger study uses this design to show that that is also not worth anything as far as future earnings goes. And it's really just telling you something about who gets to go to selective schools. So that's thought-provoking for all sorts of reasons. Okay, now I want to step back from this a little bit. And, let me show you one other thing. So there is a caveat to this because to produce those Barron's matches, I have to find people who have similar opportunity and ambition, okay? So some people have unusual combinations of schools that they applied to or that they were admitted to, and so I can't find, a good comparison. So the original Barron's sample, the original College and Beyond sample has 14,000 people. I can only run this regression for 5,583 people. So there's a lot of people that I'm throwing away. This is the people that I can't find a match for, okay? So that's maybe troubling. Yes, sir, you have a question?
One thing that comes to my mind is seeing these results. So why do people go to MIT? Is it just the prestige? Or?
Well, I don't know. This is a little dangerous for me to get into this as an MIT professor. I think the idea here is very general, which is most people are not econometricians. And the idea that observed associations are misleading is something that we bring as economists and people who are sophisticated about data. So one answer is people are fooled. Okay, that would be one response. People look and they say, well, that's where the good things are happening, and so I'm going to want to send my child there. Another is that there's something else in life besides earnings. Now, as a labor economist, I tend to dismiss that, but other people may disagree. So a former student of mine, for example, has a paper using the Dale and Krueger design to explore marriage. So a lot of what you used to go to college for was to find a spouse. Now you're not allowed to do that anymore. But and she shows, my former student shows that you'll get a better, in the sense of a higher earning spouse, by going to a place like MIT. So, but it does raise a lot of interesting questions. And I think there's a lot of our work that raises exactly that question. So let me just show you there's something that you can do here. And this is another inspired idea in this original paper, which I think is one of the great applied econometric studies of all time. So Krueger and Dale recognized that we're losing a lot of data. And the reason we're losing a lot of data is, it's very demanding to find people who, just like me, they applied to 2 competitive and 3 highly competitive, and they were admitted to 1 of each. So maybe there's a way to parameterize this in some way that's more flexible and not flexible, but more parametric, the opposite of flexible, more parametric. Okay, that's not so costly in terms of sample. So the Dale and Krueger solution for this is what they call the self-revelation model. So this allows us to keep the entire sample of 14,000 or so, and they simply control for the average selectivity of the schools that I apply to. Instead of trying to put dummies in for all these groups and matches, just put in a single number, which is, what was the average SAT score of people on campus at the schools, the 6 schools that I applied to, or the 3. And then let's also control, because this is very important as well. Most American applicants, especially, this is going back to the 70s, before the days of the Common App and everything. So most people didn't apply to very many schools. And it was really only the very ambitious who applied, to 10 schools or 20 schools. So they have the average SAT score, and then did I apply to 2 schools, 3 schools, or 4 or more schools? And so let's just review this. So here's the raw private effect. So the raw private effect, uncontrolled, is now bigger than it was. So in the full sample, the raw private effect is 21 log points. Again, very precisely estimated. Controlling for my own ability, it goes down. So controlling for my own SAT score, it goes down to 15 points. And then controlling for all the other stuff, like whether I'm an athlete and my family income, is still a good predictor. It goes down to 14 points. So it's still quite substantial, and doesn't go away just by those kind of controls. But it turns out that if I put these guys in, and here they're actually reported because there aren't very many, I knock this down to 3%, and it's not statistically significantly different from 0. So once I know the selectivity of the schools that you target, it doesn't actually matter where you go. And I can even use a very crude control for this. So that's even more impressive, okay? And it says that a lot of what's over here on the left, parental views on these matters notwithstanding, a lot of that must be selection bias. And the fact that people that target more selective schools were just more likely to have higher earnings. And very, very crude control will pick up that powerful force that generates selection bias in the college and beyond sample. So that's impressive that I can get this result in the entire data set with a very minimal control. And I've poked and played with these data quite a bit myself. It's a very robust finding, and you can code this up like in the spirit of the times. I did some machine learning exercises where I let the kind of the computer figure out how to measure. This is work with a former student, Brigham Franza. We let the computer figure out how to simplify this model, and it comes out exactly the same way. Okay, so a very provocative finding. Now, why do I think this is so convincing? So for that, we need some theory.